welcome everybody. Thank you so much for being with us today for this panel on ground robotics in climate action. We're all gathered around this virtual table in order to share opinions, ideas, questions, and excitement around how ground robots can become essential allies in tackling the climate crisis in a responsible, inclusive, ethical, and sustainable manner. We have a group of fantastic speakers today with us, all engaged in various robotics pursuits to tackle some of these climate-related issues and ready to share their stories, their impact, their hopes, their challenges, and to answer all of the questions from the audience as well. So I'll be moderating this session together with Stefana, whom you'll hear in a minute. My name is Audrey. I currently lead the field engineering team at ANYbotics. So ANYbotics builds full-legged industrial inspection robots aimed at preventing humans from spending time in dirty, hazardous, remote places while doing these inspections. So my team is in charge of accompanying our customers through their robotics adoption journey, and that means putting on coveralls and hard hats and deploying robots on these unpleasant sites. So in my role, I help remove people from dirty, hazardous places. So I'm really excited now to hear how we can avoid all of us living in a future dirty, hazardous world. And I've also learned that with robots, once in the real world, things never go as planned. So going from the lab to the field always brings unexpected challenges. So I'm looking forward to also hear the real life stories from our speakers. And now, before we dive into what it means to responsibly involve robots in our efforts towards a sustainable tomorrow, let's hear from our other moderator for this session, Stefana.
Sure. A warm welcome from my side also. I'm Stefana Parascho. I'm the co-moderator with Audrey of the session. I am a professor at EPFL. I am in the architecture department. I'm actually an architect myself, but I work on construction robotics. We develop processes that can be used for construction involving robots. And yeah, I have a particular interest in how humans and robots work together. So I would love to hear more on your perspectives on how we can bring humans and machines together. And of course, a strong interest in finding solutions that help us deal with the current climate crisis and how we can use technologies such as robotics, in particular in construction, to improve the really immense negative impact that construction has. But yeah, that's enough from my side. I think I'd be really excited to hear about all of your works and the different focuses that you have. So I think we can dive right in. And I mean, the way that this session is set up is that we will first invite every one of the speakers to present yourselves and to speak about the work that you do for a few minutes, and then we'll move on to questions and answers. If there's any questions or anything about how this runs, do let us know. But otherwise, I believe we will start with Chinmay. Soman, did I pronounce your name correctly? Probably not. Yeah.
That's
okay.
It's good. Yeah. Hey everybody. Yeah. Thanks for the great invitation. Patrick and I have been speaking for I don't know, I think like 2 years now about various opportunity for robotics in climate change, agriculture, all kinds of things. So really excited to see how this conference has come together. I'm Chinmay Soman. I'm the co-founder and CEO at EarthSense. I started EarthSense with my childhood best friend, Girish Chaudhary. He's the main robotics and AI expert. I'm really the agriculture expert and more customer-facing role at EarthSense. But we've been making ground robots for a variety of different use cases in agriculture since 2018 commercially, and then a couple of years before that internally, just tinkering around. We see a huge need for automation and AI and robotics in agriculture all over the world. Right now I'm actually calling in from Malaysia. It is 15 minutes to 1 a.m. here, but happy to participate. But the reason I'm here is that you would expect that in Asia and Africa, with so many people around, there isn't really any need for automation. But actually, the reverse is true. There are major places, major crops in the developing part of the world that used to be entirely manually farmed, but over the last 10-15 years, because of industrialization, people are leaving farming so rapidly that big parts of agriculture are severely under stress. Because let's face it, agriculture is a very well, I don't know if I would call it dull. I guess it is in some ways dull. It definitely is dirty and dangerous, and more importantly, it doesn't pay enough. So everybody wants to go to the cities, work in factories, or even drive an Uber or whatever, and they would make more money with an easier job. So farmers, landowners, agribusiness folks are looking for robotic solutions, and we've been kind of following that lead to figure out where we can make the best impact. So I'll talk a little bit more about what our robots do and why we've particularly followed those lines of value. But I'll pass it on to the next panel member, maybe.
Thank you so much, Chinmay. So I'd like Dylan to introduce himself and his work now.
Awesome. Thank you, Audrey. Hi, everybody. Really excited to be here, calling in from Brooklyn, New York, in the Navy Yard this morning, or excuse me, this afternoon. So I'm the co-founder here at Renovate Robotics. We are a construction robotics company focused specifically on the roofing industry, which is not an industry that a lot of people think about day to day, but roofing is a very climate-driven industry. So as you can imagine, roofs are the literal interface of all of our buildings and the building envelopes, and the environment and weather. So as weather becomes increasingly severe, the amount of damage to the roofs and to the building envelope increases as well. And roofing is also a very dangerous trade. It's one of the most dangerous trades here in the United States in terms of the number of deaths per year. And it's also kind of wrought with, underage labor and migrant labor that's, very much so, utilized in a way that's not very safe. So, at Renovate Robotics, what we're really focused on, is using robots to automate the installation of roofs to build higher quality roofs. And then, there's also a very clear component for climate mitigation by installing future materials like solar onto roofs as well. So our products don't only install materials like, shingles or slate or like Spanish barrel tile, but we can also adapt our machines in the future to install solar shingles or rack and panel solar systems. So I'm sure we'll get into some more specifics further in the panel, but I'll leave it there for now.
Thanks a lot, Dylan. The next one up would be Tom Lipinski.
Hello, I hope you're okay. So I'm joining from London, and I'm here to talk to you about QBot. QBot operates in existing buildings with a task of making them more energy efficient. I also come from architectural background, and I've been working in retrofit or weatherization space for quite a few years before setting up QBot, and realized that it's not really a similar challenge to new construction when we're dealing with existing buildings. We've got various different typologies. We've got buildings built over vastly different periods. It could be 200 years old, could be 10 years old. They have different orientation. They've built of different materials, and so on and so on. Complexity is much higher than in the new construction. Making them more efficient has been a significant challenge. The biggest one was trying to deal with the floor. It's floor has always been a challenging issue because you've got lots of nasties coming from the floor. If you think about it, there's lots of cold coming in, there's draft, there's opportunity for radon to come in, there's quite a lot of humidity coming in. Floor voids and crawl spaces are generally wet and soggy, especially in places like England. And at the same time, you know, we understand windows, we understand maybe loft or attic insulation. We could deal with walls, although in a very expensive way, but we've not really worked out a way of insulating floors through which you can lose 20% of your heat in a sustainable but roundabout sustainable way, not, you know, making it without waste, without extreme expense, without moving people out. And this is where QBot was born, to effectively crawl under, you know, in the existing floor voids or crawl spaces, and most buildings in the UK and vast proportion of buildings in the world, like US and Europe, have crawl spaces, to crawl through the crawl spaces and insulate the floors from below. The advantage of insulating the floors from below, obviously, that you isolate the structural timber element from the wet and cold void. You remove the timber away from the dew point, you remove it away from the moisture and humidity coming from the void, and at the same time you keep it much warmer. You also dramatically reduce drafts in a house, so you improve the U value, you reduce infiltration, you reduce humidity, lots and lots of benefits. And we started up in 2012, and at that point, you know, we spent, you know, a year building something. We took it to site where, you know, within 15 minutes it broke. So it took us about 5 years to get it to a point where we could actually show it to somebody. And in 2017, we got a BBA, or British Board of Agreement approval for robotics to work on construction, which I think was the first at the time. And started doing it at volume. Initially, we started working with social sector, we can call them public housing. We've insulated 5,000 floors by now. So it's a space where we're not talking about an idea. We're not planning to do something. We've actually delivered technology to market. We're now onto a Mark 8 of our technology, and we've spent quite a lot of money and time developing the tech, but we have actually delivered insulation in 5,000 cases, in which case that means that we're saving already something around 4,000 tons of CO2 per year by saving heating. So yeah, that's where we are.
Thank you so much. I'd like to invite Jay next.
Hey, I'm Jay, founder, CEO of Luminous. Previously had built one company from the ground up doing industrial packaging, and now, you know, very, very laser focused on shipping robots to build solar farms. So from our perspective, you know, we're trying to tackle the biggest problem from the electrification perspective, where to actually build out a solar field, the highest labor expense item is actually moving glass, in terms of like OSHA and cost expenses. So typically, building out a solar farm takes, you know, 100,000 to 1 million solar panels that are each, you know, 80 to 100 pounds. You can't lift that by yourself. So, you know, a crew would be something like 2 to 5 people lifting a single solar panel, one at a time, from pallets to racking infrastructure. What we're focused on at Luminous is building fleets of robots that are laser focused for this specific application. So how do you parallelize the deployment of lifting and securing individual solar modules in the construction site? So happy to dig in more, but I want to keep my intro short, so go into Q&A.
Thanks so much, Jay. Our last speaker that I'd like to invite is Ben.
Hi, everyone. Nice to meet you all. Calling from Tel Aviv. Following on Jay and complementing what you're doing, I'm co-founder and CEO of Soltrex, and we're automating solar energy plants operations in the lifetime of the operation of the plant. So basically the entire 30 years of the solar plant lifetime in the sense of operation maintenance that is mainly conducted today manually. So we're talking about panel cleaning and grass cutting, inspection of all sorts of thermal inspection, visual rounds of inspection, and even security rounds. So all these tasks done basically manually are increasing the levelized cost of energy, and there's no perfect use case for automation than solar energy plants with their routine maintenance. So this is what we're doing, and I'll be happy to dive deeper.
Great. Thank you, everybody. So let's start with a first question. So we all know that the climate crisis isn't about saving our planet; it's about preserving life on this planet, right? So fundamentally, what we do has to be about and for living beings. So how can robotics and the proposed technologies contribute to improving humans' working and living conditions beyond offering economic gains? If you want to
start with food. Sorry,
go on.
Were you calling on somebody in particular?
No, you can all jump in as you feel comfortable. We'd love to hear from everyone or whoever wants. Like, there's no pressure.
Okay, all right. Yeah, I mean, I feel like food is kind of at the heart of our existence, and it's also one of the most impactful ways we interact with the natural ecosystems. Many bad, but potentially could be very good ways to interact with natural ecosystems around the world as well. So I can dive into a little bit of why EarthSense does what we do. So we have a whole family of robots that at their core use the same AI and autonomy capabilities. We call it the Terra AI. And our first product that we commercialized as alpha, paid alphas in 2018 was for crop scientists around the world to help create the next generation of more productive, more sustainable, climate resilient varieties of crops. And their biggest bottleneck in being able to do that was figuring out which varieties worked well under what conditions, and which varieties were more heat tolerant, drought tolerant, fertilizer efficient, disease resistant, all of those kinds of things. Even as of now, because our robots are unfortunately not universally deployed, there are many agricultural research and product development projects that send out just people walking through these fields, measuring plants by hand, kind of subjectively rating plants by hand for all of these varieties of things. And that's kind of, really slowing down how fast we can make our primary food system much more climate resilient, and adapting to these conditions that, as far as I can tell, we're pretty much locked in for the next 30, 40, 50 years, unless somebody invents really fast way of doing carbon sequestration. But speaking of that, agriculture is actually one of the really solid solutions for sucking up the excess carbon that we have in the air, and not just locking it away, but actually putting it to good use. So our second product, the Terra Preta robot, is these are robots that work in teams to not just understand what's happening on the field, but really at a large scale plant what's called cover crops. So these are crops that are specially selected for their deep roots to grow during times that are not optimal for the primary crop to grow food, for example. So in the Northern Hemisphere, in US and Europe, most of the farmers are growing their main crop from June to October. And then, November through next May, many fields, almost all fields, are just lying fallow, which means they're losing carbon, there's erosion going on, there's loss of fertility, and it's just a big hassle. And cover crops, while they're well known as a technology, like plant seeds, plant types of plants that just cover the ground and improve the soil, farmers haven't been able to do cover cropping at scale because it's costly, labor intensive, and takes amount of tuning, several years of fine tuning before they start seeing their economic benefits. So we made that easy as well. And then finally, just to end on a little bit of a spicy note, we also see that there are, crops in the world, like agriculture, wherever, however we do it, has some negative effect on the environment. If we weren't farming in these places, most of these places would have some kind of a natural ecosystem. But at least for a while, we are locked in for some of these crops. Corn and soybean agriculture in the US, for example, is like 200 million acres of just monocropping, right? It's not a great system, but by the same token, if we just vilify it, that's not a solution. We have to figure out how to improve it. We've approached, the reason I'm in Malaysia is to deal with another very, very problematic crop, which is oil palm. And oil palm has really exploded over the last 10, 15 years. And ironically, in large parts due to the sustainable biodiesel mandate imposed by or adopted by the EU. And now that they've seen the impacts of like, okay, oil palm is causing deforestation, maybe some of these peatland ecosystems are emitting more carbon than European drivers are benefiting from the biodiesel. They're kind of pulling back from it, and oil palm is going through a really strong period of public censure, if you will. But again, like just vilifying them, I don't think is a solution. So we've started working with some of the thought leaders and action leaders in this space to figure out, okay, yes, oil palm, there's 30 million hectares of it. It's not going away. It's the most popular, most consumed food oil in the world. And let's figure out how to clean up that space. Let's figure out how to make it a net positive for the world by improving productivity, improving labor conditions, as well as maybe turning all of these hectares that we have into carbon sinks rather than a problem. And if we can increase productivity on oil palm plantations that are reasonably, converted from farmland, then we can let go of some of the oil palm that has come online in the last 10 years by deforestation. Maybe we can start reforesting, hopefully, on that land again, because we don't really need to farm in these faraway problematic spaces where, nobody likes to farm on the hillside. It's hard to mechanize. So let's release those farmlands back to the natural ecosystems. So that's kind of the space spectrum that we're looking at, helping farmers get better inputs like seeds, helping farmers improve their soils, and then helping farmers improve the productivity and labor efficiency of their agriculture in general, regardless of what type of crop they're working in. So the generalized autonomy and AI system that we've developed is really geared towards creating a range of different robots that help agriculture worldwide as a whole become much more productive, profitable, and climate resilient and sustainable, and a climate solution, actually. So that's kind of how we see the need for robotics in agriculture. I think we desperately need it because conventional solutions like tractors are only going to go in one direction, which is just make agriculture more and more monoculture, more and more resource intensive, more and more a climate problem than a climate solution. That's my spiel to
Thank you so much.
Off.
Anyone else wants to jump in and give their opinion?
My question would be, what specific problem? I mean, are we just trying to tackle climate problems? Are we looking at any specific issue that helps us to tackle the climate problem? Because we've got people that are dealing with energy generation here, right? The PVs and keeping PVs running. We've got people that are reducing the, improving sustainability of food production. We obviously can't stop eating. My view is, most of the buildings that are standing by 2050 have already been built, right? This is the biggest challenge we've got. If you look at UK and Europe, we renew less than 1% of our housing stock per year, right? So new buildings and new construction are not a challenge that will take us, will take us to our climate targets. It's dealing with existing buildings, and we are dealing with proportion of that. When you look at existing buildings, it's not just the operational carbon, it's also the intervention that you introduce in order to make it more efficient. I've seen some retrofit initiatives such as, I don't know, Energy Sprong, which is very sort of technological and it appears resource intensive. And if you're spending 15 years worth of carbon budget on making an intervention in order to make a building more energy efficient, well, you're not really going to have a positive impact on that until you've saved enough to pay for that carbon budget that you've just utilized. So it's just this holistic thinking that's currently, that might be missing. I mean, we've seen a case of I don't know, there was a Bloomberg building put up in London, which won lots of awards for being the most sustainable building built that year in London, and everybody was super proud about it. But the fact is that it will take that building 50 years to work off, through their low energy consumption and so on, to work off the amount of carbon that was emitted just during its construction. So it's what we trying to do, the focus that we have, and this is where Hubert really tries to make a difference, is if you come and deal with an existing buildings, and by trying to make them more energy efficient, you actually create a hell of a lot of waste. You use lots of new resources, and are you really achieving the objective? Yes, the end result will be a more efficient building, but if it'll take it 15 or 20 years in order to work off that initial, embedded carbon, then you haven't really done anything, because for another 20 years, that building is still paying off its debt. So the way we look at this is, instead of ripping anything up, we crawl underneath the existing floor, and you retain the whole thing. Unless there's a rotten joist or something that really needs replacing from the perspective of structural integrity of the building, we try to retain what's there. And in our case, it's almost like a keyhole surgery for buildings, and then we do the intervention and we'll leave it with as minimum alteration as possible. In fact, once we've insulated the building and you've got your comfort savings, and the building stays cooler in the summer because there's less draft coming through and warm in winter, you wouldn't actually be able to tell visually that anything has been done. So you retain that historic value of the building. You're not covering a 200-year-old building with a magnolia colored goo. That's another thing. So my take is, it's not just making things efficient, but also trying to preserve as much as possible, so people can enjoy architectural heritage as well in the future. So yeah, that's my take here.
Thank you so much. Does somebody else want to provide input?
And it can either be related to the initial question, like in particular, how we improve conditions for people, for workers, etc. Or of course you can reply or continue on Tom's input.
I can agree with some of the things you said, Tom. I think an interesting objective function is like, you want to make things more more efficient, but at the same time, you really have to weigh the cost to get there, right? So like you said, paying debt back in terms of the carbon emission to get to a building that's much more efficient But having the debt be 15, 20 years may or may not be necessarily the best approach, because I think some of this carbon emission reduction is kind of a immediate need, right? Like there's so much urgency to be done within the next decade, 2 decades, where introducing additional carbon emission may not be the optimal approach. So, totally agree with that.
Yeah, like, maybe just echoing off of that, I think, yeah, the challenge here is that there's a lot of like complexity and moving components, and that there's no, singular organization that's owning the whole stack of like the point that you're making, Tom. And then even Jay, to what you were saying, I think we can all agree that there are industries or like segments where we have agreed that in this moment, increasing emissions is a good idea to decrease emissions in the future. And that we'll just end up solving those problems later. I think the biggest example is in electrification, right? And the amount of resources that we have to pull from the ground and the amount of critical minerals that we need today to meet the electrification targets that we have over the next 20 years is kind of insane. And there's obviously going to be an immediate impact of that. But I think there's a bet that people are making that, okay, if we can get those resources in the short term, in the long term, we can find a way to create the circular economy that makes that a good idea. Yeah, so I think there's areas where that makes a lot of sense. I think there's areas where that makes a lot less sense. Like in the roofing industry, it's like an inherently cyclical industry. So, in Europe, or maybe some of the areas where you all are calling in from, when a roof is installed, it probably lasts for 100 years because it's a stone roof or a tile roof or something like this. And maybe in your climate, there's not like hail or tornadoes or things like this. In the US, the most common material is what's called an asphalt shingle, which is a shingle that's made of a combination of asphalt granules and fiberglass. And these materials only last about 17 to 20 years. So there's an inherent cyclical nature of the industry. The roof is installed once, and then 20 years later, it's installed again. And you might replace 5 or 6 or 7 roofs over the lifetime of the building. And what that's resulted in, from a circular economy and sustainability perspective in the roofing industry, is a focus on, what happens to those materials after they're torn off. And you see a lot of manufacturers today thinking about, okay, how do we collect those materials? How do we create waste streams that can autonomously, process those materials and turn them back into shingles again, and what have you. And they have the ability to operationalize, I would say, because it's already this cyclical industry that has an end customer. That end customer is both installing the material, moving the old material that was on there 20 years ago. But there's many industries where that's not true, right? When that Bloomberg building, for example, that you mentioned, Tom, is torn down in 100 years, there's a question of what happens to that collective, product that's all torn down. Is that sorted? How is that sorted? What happens to it? Who's responsible for it, et cetera? Yeah, but it's certainly a very interesting question.
I can maybe jump in to move a little bit the question as well, but I very much appreciate the inputs, especially from a construction perspective, where I think we think less about how can we build new and build more, but we have to think more about how can we preserve what we have and how can we use less resources to do this. Maybe not in that context, also related to what you mentioned, Dylan, that there are these cyclical processes which actually can be quite sustainable. It's not that if you have to replace and redo it, it's a bigger impact. Sometimes, parts of buildings, for example, that are not easily replaceable, instead of fixing something locally, you then have to change the entire facade, and that's obviously a lot less sustainable than what we can do. But it also reminded me that many of these processes that we're looking at, they're currently done by manual labor. They're currently done by people. And part of them are also really craft-related processes. It reminded me there's actually wood shingling in Switzerland, which is a very manual craft that requires a lot of expertise or a lot of skill. So I'm just curious to hear from everyone. I really don't want to get stuck on the construction questions only. But, you know, what is your perspective on really the way that that we deal with people partially being replaced by robots, the feelings that people have towards that, the way that the robotics field is also viewed from the broader population. What I think there's a lot of conversations going on. People are not always very apprehensive to robotic technology for this reason. And yeah, a little bit how you see this, and also how you discuss these topics in your fields.
Sure, I'll be happy to take it. Yeah, so I think when we're looking at the topic of our conversation here, Climate Robotics Summit, I think all of us, you know, basically are focusing on replacing humans in work that are, let's say, a must replace, like either because it's dangerous, if I'm referring to Dylan, or not efficient. But when we're focusing on building solar plants and maintaining them, I think it's a global effort in making, in moving into solar energy or renewable energy, where 75% of emissions is from fossil fuels emissions. So in that case, we have to act now, and we have no time, and we must do that as fast as we can. So that is one perspective, you know. The robotics add to what we're doing here, and a second way of looking at it is that if I'm focusing on the solar industry, then most of the jobs still don't exist, meaning most of the solar plants that need in order to power our planet still are yet to build. So these are jobs that are not yet in the market. Yeah, so this is my perspective of your question. Thank you.
Thanks a lot. Anyone else wants to chime in?
Well, you've asked an architectural question, right? My view, and I don't know if this is what's going to happen, but if you look at other industries, as automation takes over, you end up with a large proportion of output being generated automatically, and it goes down in cost and it improves in quality. So when you look at car industry or clothing industry or whatever, and then you have this move on at the other end towards that sort of artisan, high quality craftsmanship, right? And at the moment, the construction industry is neither, right? We have hand bodged in volume, where quality is woeful, right? Where there is no quality control, where outputs are variable, where you've got delays on every project and so on. So neither it's this sort of artisan quality aspirational output, nor we have the volume cost effective output at the other hand. And I believe that as automation and robotics slowly take over construction, and to be honest with you, I can't personally wait, then some processes will be volumized. There will be a lot more offsite construction. Even when it comes to existing buildings, we'll have a lot more quality control, a lot safer labor. We'll have robots doing the repeated manual tasks, and we'll be able to actually have something of decent quality. It should make construction a lot more accessible, cost effective, you know, less reliant on builders who are always busy and run off to another job, whatever. And then you'll have that sort of maybe heritage related, highly skilled I wouldn't call it niche. I hope it's not a niche, but people that can work with lime mortar, people that can really build, a brick arch, people that can focus on retaining existing buildings of cultural value. And as buildings get older, probably more of them will end up being in that sort of cultural, but people that can, I don't know, build a timber window to replace the existing timber window, which you can't mass produce because it's unique. It's got unique size and shape, and it's not something repeatable. So I think there will be, people will value the real skills more, and hopefully the construction sector, will become more artisan in that case, providing more value. But at the other end, you'll end up with a lot more volume-driven, automated construction, which will hopefully improve access, improve, cost and quality of the sector, and hopefully sustainability with it.
So that was a very interesting perspective that I hadn't necessarily thought about in those terms. But in agriculture, we've kind of already seen this move from artisanal to industrial mass manufacturing, right? And it wasn't done with, quote unquote robotics. And in some ways, it was, with tractors, the reason that we have only corn and soybean, to a first approximation as the dominant crops in North America, and a lot of homogeneous, monocultures happening in Europe and South America as well, is because we've taken people out of agriculture, but not replaced them with, the way I envision robots, but we've replaced them with machines that, as incredibly sophisticated as they are from an engineering perspective, they are really, really dumb, right? So if you have a corn optimized, planter or harvester, you can only plant millions and millions and millions of corn plants all together and work with corn plants all together. Whereas, where I see and where I'm driving at EarthSense, we're driving agricultural robotics towards is in fact bringing back the biodiversity into agriculture the way people used to do it on a very, very small scale. That's been taken away because the economics of scale to using these $1 million tractors is that you have to farm thousands of acres of the same crop. But if you have a number of a range of different robots that are each specialized at different tasks and that are much more dexterous, that are much more capable, intelligent, quote unquote, by themselves on the edge, then they can deal with that kind of diversity that we actually need in order to not only make agriculture more climate resilient and a positive force on the climate, but in fact, you get much more productivity out of those systems as well. If you just don't focus on like, okay, how many calories am I getting out of this acre? And you also start to value other things like carbon sequestration, ecosystem services, and of course, yield that stays consistent. And because you're farming in a biodiverse way, you have a diversification in your portfolio, if you will. And a disease that affects one crop doesn't affect the other crop. And in fact, you can smartly design these biodiverse agricultural systems so that their net benefit, there's a lot of synergistic effects that come from that biodiversity. And all of that used to be how people used to farm, or people used to farm in an idealized view of it, if you will. But we can bring that back with smart robots. We cannot bring that back with conventional mechanization of agriculture. So I really like this idea of like how other industries would bifurcate towards volume at one end and artisanal nature at the other end. I think in agriculture, our vision is to enable artisanal agriculture at massive scale around the world, because that's really the only option to go. And we've tried the other thing already in agriculture, and it's bad. It's bad for everybody. It's bad for farmers. It's bad for the planet. It's bad for consumers' health, everything. So let's try the other thing now.
Thank you so much. Yeah, see, John has raised his hand. So I'll let him speak in a second, and I'd just like to tell people who asked questions in the chat, we'll just open the discussion. You can raise your hand and ask your question directly orally. So, John?
Thank you very much. So just to introduce myself quickly, you probably guessed from the badge that I work with Tom. I posted in the chat. I've been working with Tom since January. Absolute delight to come into the clean tech, climate tech space in robotics. I spent the previous 5.5, 6 years working in medical robotics, bringing a startup keyhole surgery robot in the UK to market. And I just wanted to draw some parallels because I think they're kind of relevant. So one of the things I find really exciting is the skills preservation piece that robotics enables. We've got an aging workforce in construction, or aging workforce in many of the sectors that we serve. In the case of the surgery domain where I was working before, I worked closely with a world-leading surgeon based in Delhi. His name is Dr. Chaubey. Dr. Chaubey started performing laparoscopic surgeries in 1984. So he's been doing that for 40 years. And with a robot, he's able to do more than 100 surgeries a month in his, I don't know exactly his age, but I'm going to say mid-70s. This is a man of absolute exquisite skill who would otherwise have stopped helping people with his tools because he would have suffered from backache, neckache, all the strain you get from repetitively doing the same tasks. So I feel like construction industry has that opportunity to take people who know how to look after buildings, or people who know how to use those skill sets, but might otherwise have stopped or possibly have bodily injuries or disabilities, maybe even gender discriminatory situations and this sort of stuff. Robotics actually allows people to bring those skills into difficult environments and continue to deliver that experience without the strain and the discomfort of those spaces. So this is a space I think is a leverage opportunity for us in this sector. Is let's not forget that we're not ridding people necessarily of the jobs. There are going to be jobs lost with robotics and automation, that's clear, but we're also enabling some of the highest skilled and most valuable jobs to continue to give back for a long time to come. And I was super inspired by that working in the medical space, and it's a piece that I'm very excited about when I find that we operate our robot with a games console, so teenagers who've not come through construction industry can pretty much walk straight into our robot space and get a career in underfloor robotics if they want to, because the skill sets they've learned on the games console are completely applicable. So it takes down some barriers to entry, but it also extends the working life of the workforce. So I thought I'd share that and see whether other people find that echoes in their industries.
Thanks so much. I see that Jay, I think, raised their hand first.
Yeah, and to build off what you had just said, the original question was like, how do we feel about potentially replacing people as we ship robots? Luckily, from our perspective with the solar construction industry, it doesn't really exist too much because we have such a huge labor shortage in the United States already, that the gating factor is that we can't have sufficient people to go deploy up these solar fields at the capacity we would like to hit our 2030 milestones, right? Like these fields are, in really remote areas where even if you could source, 200, 300, maybe even 500 people, that geographic location does not support that many people, living there simultaneously at once, So not only that, I think John had also brought up a really interesting point where we're not necessarily removing people from the existing process. What we're really doing is empowering the existing labor to do more, right? So there are people that are trained master electricians, journeymen that are working on these solar fields and building out these solar fields and, lifting heavy equipment, but, they would much rather be doing electrical work, stuff they're trained to do, and not lift things over and over. So how we think about it from our perspective is that we're shipping robots to allow people to do more and kind of scale out their operations that way.
Thanks a lot. We have Dean who had a question, comment, and then Mitra.
Well, I'm a software engineer. I'm not presently working in a robotics company, but the question about putting people out of work, as I see it, I think robotics will cut the cost of things so much that projects that were not feasible or economically feasible will become feasible. A good example of this, in the United States, you have facilities that will sort recycling. These are referred to as material recovery facilities, and they're referred to as clean MRFs because you're sending clean material to it to be sorted. But very few, what they refer to as a dirty MRF, which is all the other trash, everything else you throw out, doesn't get sorted. And the reason being is that, one, it's very dangerous to expose people to this material. You have no idea what people have thrown out. A cut or with something could be infectious. This the insurance savings on the people alone would pay for the robots. So if you could build a dirty MRF that used robotics, you could then sort all the trash that would go to a landfill or something and redirect it to a more appropriate recycling, and even maybe eventually put those recycling abilities right in the trash truck. They're going in the trash truck, and you can sort them well enough that it becomes economically profitable. And once you make it profitable, you don't have to force people to do it. They'll do it of their own free will to make money. And so I think that's where the future is. A quick story, when my daughter was young, we were watching Bob the Builder. Everybody remember that cartoon with your kids and stuff like that. And she one day described it as a builder working with his friendly robot tools to build stuff. And I was like, yeah, those characters were robots that he was given instructions to. That is where we're not going to replace people, we're going to augment people and be able to cut the cost. So the cost of building new housing, the cost of fixing roads, the cost of maintaining bridges will all come down, so we're not constantly panicking to fix these things and keep them maintained. That's just my thought. Thank you.
Thank you.
Thank you so much. Oh, sorry. Go on.
No, go ahead.
Thank you so much, Dean. I think Mitra, sorry, I don't know how to pronounce your name. You're next.
Yeah, so I just had a question. It's Mitra. So just my question is kind of inspired by what has been said before. So we kind of, I guess what I'm getting from all the speakers is that we kind of agree that basically humans need to replace, robots need to replace humans, either to perform tasks that is not manageable by humans, or to make it happen faster. So it's kind of the agreement among everyone that is talking, no matter what kind of field they're working on. But then considering what Ed Carr said earlier during the sessions, he was saying that what he's afraid of is that there would be an issue that we haven't seen before, we haven't thought of, and then it just pops up as climate gets to be more extreme and we get closer to face with the climate change. So that is one thing that I would like ideally every speaker to comment on and think of what is unthinkable. And also I wonder that my second question, again, I like to have the comment from all the speakers, is that what would be a startup that you would advise? And considering that all the promotion of interdisciplinary fields and how people should get together, like how do you think your field of work, which seems to be quite different from roof design, architecture, and agriculture, can kind of create a synergy and be brought together? Thank you so much. And I hope I hear from all of you.
Thanks, Mitra. Excellent questions. Yeah, go ahead.
Yeah, I was going to jump in on the second one. I mean, I think we're doing it now, which is great. This, I think this is a big component of it. you know, as many of you know, like being founders on this call, you know, I think what a lot of us spend our time doing is crafting our story and sharing that with investors and fundraising and putting time and effort towards finding the capital and the resources necessary, whether that be money or whether that be human capital or resources, et cetera. You know, I think the more vocal we are as an industry and as a group of people focused on these problems, you know, the better it is for everyone. So I think, you know, participating in events like this, you know, being loud and excited about what we're doing, really, I think is a rising tide that is going to raise, you know, all boats and make it easier, you know, for us to do all of the things that are required to make this possible, whether that be raising money or finding people who believe in us to join our teams, et cetera. You know, and I think it's a thing I've been spending a lot more time thinking about lately as well. You know, I think everybody on this call, I think, feels very strongly, given your presence here, you know, that robotics play a very important role, you know, in the climate transition that we're in and in the solution. And I think the more vocal that we can be about that and the more people that we can convince, the more compounding impacts it's going to have on getting us where we need to be.
We would really love to hear from everyone. So feel free, no pressure, but a bit of pressure.
I'm gonna
I think
make an
that.
attempt.
Go ahead.
That's okay.
Go ahead, Tom.
So we're talking about these fields of, let's say, you know, the energy generation, the built environment, and the food provision, which is pretty much, you know, that's what we need for survival, right? We need energy, we need food, and we need shelter, right? How will these disciplines combine or unite in order to sort of create that sustainable future? And it could go one of the two ways, to be honest with you. You could have that sort of, because our homes will become more automated and they will become intelligent. I mean, it's just a you know, a matter of time. They will be sort of managed external skeletons effectively, and the agriculture and everything else. As it all becomes more automated, it will become more connected. It's just again, it will just be a one big network. Now, you could have that open connectivity that enables that sustainability and circularity on a large scale, where every building or every community sort of acts as part of the larger whole, like a mycelium. You know, effectively, we're looking at one big network, and within that network, everything is connected and sustainable. And that's very sort of, call it open source mentality. But at the same time, you could have that survivalist view where you've got this energy generation and food production and that circularity in a closed loop way, with, you know, buildings becoming almost self-contained fortresses. You know, when you've got PVs on the roof, you've got vertical gardens in a basement, and you've got, you know, the well in the garden, and they sort of, you know, that circularity and that sustainability is a much smaller loop, much less productive, because obviously you don't get the network effect, you don't get the specialization, but it could go either way. But it will be around some sort of built environment, land, you know, and the energy provision aspect. And the question is, which way is this going to go? So have I thrown in a Mad Max reality here?
A little bit.
I guess it depends if we can stop at 2 degrees or not. You know, as we cross 2 degrees, it will become a much closer loop. The networks will shrink, and the circularity will sort of really wrap around very small communities. But if we can stop below 2 degrees, you know, we can still afford the openness.
I mean, yes, things will become more and more challenging as average temperatures continue to rise, and if they, you know, breach any of these barriers, there might be all kinds of non-linear effects. My gut sense, though, is that gut sense and where I see trends going both on the energy side and on the intelligence side, like AI side, is that we're going to be able to cope with them. I mean, it's going to be hard work, but we're going to be able to cope with them. And then I will push back against this idea of, becoming insular, although politically the world is heading in that direction because that's kind of what everybody is freaking out about, saving themselves. But I think that reduces the networks that we have access to, that reduces the cross-pollination of ideas that happens in a highly globalized, interconnected, highly networked society. So for what it's worth, I think, the future is that I'm quite optimistic. There's going to be climate change, but we're going to do it everything we can to counteract it. And we are well placed to do it given how cheap energy is becoming, especially with folks like Luminous and Soltrex basically making solar power free or helping reduce the remaining parts of it, right? Like the modules are super, super, super low cost now anyway, right? The construction is where the headroom is for reducing the cost. The ongoing monitoring and management of the solar panels and other types of renewable energy sources is. So smart people are working on those problems. So I'm factoring into my prognostication about the future really, really low cost and abundant energy. And that helps solve a lot of problems. And then the problem that we're working on is assuming that energy is abundant and really, really low cost, then the problem to solve is of AI. And this literally goes back to the founding thought at EarthSense. Like, okay, we're going to have as much energy as we want to do whatever we want. We're going to have people that are going to want to do good things, but they're going to be limited in what they do. And there are some jobs that people just shouldn't do, like agriculture, for example. Like we could do highly biodiverse, highly productive agriculture if we send 70% of the population back to farming. But that would be a horrible idea. We have recent proof of from China, from all kinds of back to the land movements where people were forced back to the land. That's a terrible idea. But we should use robots to do agriculture in a much better way. We should use robots to do a lot of things in much better ways, which means we need the AI and the physically embodied AI to do all of these tasks that we need to do and in large parts to counteract climate change and survive and thrive in the face of climate change. So I'm going to do everything I can to avoid the Mad Max future, as I'm sure everybody here is, doing their best, right?
Yeah, let's hope so. I see Dean raised his hand first.
Well, I understand that a lot of people, the human mind is biased towards negativity because we want to make sure bad things don't happen. But there are good things happen. I mean, myself, I work from home now. I now walk. I know all my neighbors every day. That I used to get in the car and drive for an hour and a half, and now I never met them. Okay, 10 years from now, I'm going to walk into Walmart and buy a robot that will do farming in my backyard because I want a garden, but I don't want to go outside and dig in the dirt because that's just not me. But I'll buy a robot to do it for me and plant them. I'll go on my website. I'll lay out the garden. It will order them, plant them, harvest the vegetables, and leave them on my back doorstep for me. I'll have that garden, and I'll share it with my neighbors, or I might bring it to the farmer's market or something. But we're going to have so much more flexibility. We're going to have decentralization is a good thing. It's not leaving the Mad Max. People are moving out of the cities back to the country because they can now. And it's going to go in a cycle. Most people worked from home 100 years from before factories and things like that. People work from home. You're going to get decentralized business. I saw an article, it was a while ago, about somebody making a manufacturing system, a robot to make shoes. Now, but it was designed for a small business to be a cobbler again, which hasn't existed for 150 years. There used to be a cobbler downtown in your town. It went to a factory. That factory went overseas. Now it's coming back. A robot's going to be, you'll be able to walk in there, have them fit your shoes, design them, pick a custom pair, and they'll be able to produce them and able to compete with Walmart. This is going to bring things back to the downtown. It's going to bring back. So there's going to be a lot of good and flexibility that's going to allow people to live the way they want. And I think people like living in small towns. I do. You know, so we could be a little bit more positive, I think. Thank you.
Completely agree. Yeah.
Oh, sorry.
Just one quick thought on that. Like decentralized but highly networked. I think that's a positive future. Decentralized and insular is the sort of, doomsday scenario, and it's a downward trajectory.
I'd like to slowly move towards the final questions that we have, but if Maitra or John, I see your hands up if you have a very short comment.
Yeah. So what I wanted to say is that basically when I ask everyone to think about the unthinkable, it was not really the ultimate response. But for instance, as everyone was talking, what I was thinking about it is that, for instance, there are these adverse effects. As there are more solar farms, then there is an adverse effect on the agricultural farms that are close by. This is not something you can see beforehand, before you have implemented and you have seen it. So what I wanted originally people to think about, and how these fields can be linked, can have interactions. Like these are solutions. These are solutions that are not really interacting with one another. So what could be the adverse effects while all of them are aiming to bring a positive solution? So that was my original basically question, but I guess I wasn't very clear about it. So yeah, that would be nice if I can collect some idea on that too. Thank you so much.
Thank you. John, do you have a quick comment?
Yeah, it's a quick comment. Yeah, no, I'll join Dean in a level of optimism, but I think the reality of the future is actually more urban than less. We've already gone past the 50% point about 15 years ago. We're over 4 billion people in the world living in cities. So some of us might have the freedom of choice and the opportunity to live in small communities away from the city, but most of the world's population is going to be in high density megalopolises, or unless they collapse. So my view on that is the solutions we have individually day to day are great, but the ones that make the most difference are the ones that decarbonize our cities and our transport networks inside and outside getting to and from cities. Those are the things that will, for the most, get most bang for the buck, minimum effort, maximum return. So I love all these other little fun things you can do, growing garden, vegetables and all the rest. I'm not suggesting Dean's wrong, I agree with him, but in terms of most of the world's population, it's an irrelevance, unfortunately.
Thanks so much, and thanks everyone for the very varied and open input. I think it's a great conversation, and we could continue it for much longer. I do want to leave a little bit of time just to go through each speaker and hear your last short thoughts. Also, to hear from you where you're at right now. We have a few questions on like how could the community, the broader climate robotics community, support you, whether you're hiring right now. That's something to hear. If you're looking to launch new projects and in other contexts, other countries, if you're seeking funding, just give us an idea of what your situation is. And also just the final wrap up, if you have a hot take, any sort of provocative point of view that's maybe not shared by other people, we'd love to hear that. So I mean, I'll just like maybe I'll call out Jay for no particular reason, but just we go through all the speakers if you're fine with that.
Yeah, for sure. I guess a quick final thought. There was a point about agrivoltaics. It was something that popped into mind. Building out solar fields and having that land for agriculture is not actually mutually exclusive. I mean, there are definitely existence proofs of having that synergetic way of deployment, although 90% of solar fields are not that as of today. I think there is a great avenue and trajectory for us to kind of potentially get there in the short term, medium term, and potentially for the future as well. I guess there were a ton of questions. So to wrap up, where Luminous is at is we are, shipping our robots, building out solar fields, initially in the United States. We have been getting a ton of inbound interest globally. We completely bootstrapped as of now. We are fundraising. But from our perspective, it's more about bringing on the right partners for our fundraising process. So we haven't had like a deathly need to kind of close capital ASAP. So we've been just kind of shipping out robots and ramping that process up as of today. Last thing, if I remember correctly, was like a hot take. I don't really have a crazy hot take, but I think from my perspective, it's just some things in the climate industry. We should be a little bit cognizant, I think, how we do our carbon mathematics. I think there was a point that was brought up where deploying a solution that may take more, that may generate more carbon emission than it saves could be problematic. But I think it's more about kind of understanding end to end and all the carbon mathematics involved in there to really ship a product and solution that at the core, fundamentally provides impact to the globe.
Thanks so much. Thanks so much, Jay. Maybe Ben would like to go next. So it's like, where are you at? Hiring, looking for funding partners. How can we support you? And what's your hot take?
Thank you very much. So we are at a point where we have completed our proof of concept development not long ago, signed a few first pilot agreements, and looking forward to fulfill them. Right now we are fundraising, so perhaps finding funding partners, good, true partners to this journey. That will be a great thing to go out with from this summit. And I don't have any great top hot takes. Perhaps that, if we're going back to automating and taking jobs. So, I'm looking at our world and we have so many problems around us in so many different areas. And if we're able to take out, the focus that could be replaced by automation, to let our mind and creativity focus on other world problems. So that could be a good use of our human brain and our way to face general world problems. So that's my take. Thank you very much.
Great. So Dylan, do you want to go next?
Sure. Yeah. Awesome. Always fundraising, as you know, and always hiring. So, obviously there's potentially some competition is we're a little bit horizontal here. But yeah, if you know folks here in the US, specifically in the Northeast, that are excited about, what we're working on, happy to take introductions. We actually just kicked off hiring for like 5 additional roles this week. So a lot of hiring going on our end. In the middle of fundraising. So I've added, I think a lot of you on LinkedIn, I'm sure some of you I'll be bugging about investor introductions of people that are already on your cap table, if you would oblige. And then as far as hot takes go, I think this room is the hot take, and what we're doing here is the hot take. And I think that there's a lot of people outside of this space, that would disagree. And I think it's our imperative, as people that believe in this, to go out and spread the word that robotics and automation technologies are an important imperative in the climate solution, and that we should be doing everything that we can to allocate resources to thinking about, how these technologies really can accelerate progress, R&D, discovery, the deployment of solutions into the real world, and so on. So I think the secret is that we're the hot take for the people outside of this room.
Thanks so much. I love that. I'll keep it in mind. And then we have Chinmay, the last one. Unfortunately, Tom had to leave.
All right. Yeah. So we are actively fundraising right now. We are in conversations with a couple of major ag tech funds about their doing diligence as being potentially lead, but would love introductions to investors you think would be interested in backing our play and joining us on this journey. We are also actively hiring in India, in the US, in Malaysia now, on both technology development as well as commercialization side, sales, post-sales support, all kinds of roles. So yeah, absolutely working on that. Hurdles, basically, I think agriculture might be a little bit unique about this because you kind of, farmers by necessity and very logically are very conservative in terms of adopting new solutions. And it takes several cycles of product validation, testing, improvement for it to catch on and to really start having an impact. And as a startup, those time delays can be killers, but we've managed to sort of cobble together a variety of different, strategically put together, I should say, a variety of different use cases and laddered our way towards larger impact. Hot take, I think I was gonna say essentially the same thing Ben mentioned. Robots should absolutely take away jobs. There are a huge number of jobs that people should not be doing. People should be focusing on creative problem solving, creating the new futures, and not just do stuff because it needs to be done, therefore it needs to be done by people. And farming absolutely is one of these places where, if you want to go out and pick apples as a hobby on a weekend, or as a recreational activity on a weekend, fantastic, that feels great. But if you have to do it day after day, year after year, every day in the hot sun, that's a horrible way to be a person, right? So we should be freeing people from having to do these kinds of jobs and helping them create a better future together. I think I see 10 billion people as a tremendous asset for humanity. How can we get 100 billion years worth of progress from these 10 billion people spending time on creative, progressive tasks? And one thing that we need to do is actually get robots to take away all the drudgery. But let's just recapping what Ben said. So I'll toss in another hot take. As bad as oil palm has been recently under public scrutiny and facing all this public backlash, I think it's absolutely worth saving. Oil palm farmland produces the most oil of any oil, 6 times as much as soybean, which is the next most productive one. So if we wanted to produce as much oil as we need for the growing population, we'd need to destroy a lot more ecosystems to do it with soybeans than to do it with oil palm. And the flip side of that is that if we release an acre of deforested farmland and reforest it in the tropical climates, that actually results in much more biodiversity recapture, biodiversity generation. So we should all pitch in and figure out how we can help the oil palm plantation people clean up their act and become a more sustainable, more planet-friendly way of providing the oil that we absolutely need.
Awesome. Thank you so much, everybody. I think we can wrap up this session.